Hello, everyone. Thank you for joining us today in our 2025 Snack and Learn webinar series. We will talk about nature-based climate adaptation for coastal, harbor, and urban areas against storm surges. So we will have our presentation, and after that, we will have some time for Q&A. So please drop your questions in the chat box, and we will address them at the end. Also, I want to remind you that we have a copy of this presentation in the handout box, so you can download it from them. Thank you so much for joining. I'll pass them to our expert.
Thank you, and again, thanks for joining this webinar on nature-based climate adaptation for coastal harbors and urban areas against storm surges. The image here on the front page is from a severe storm surge we had here in Denmark in December 2013, and it's an example of what the future sea level rise will do. It will increase the impact of even smaller storms. My name is Christian Heldig. I'm a senior principal coastal engineer here in WSP in Denmark. I've been working on coastal protection around the globe for the last 25 years. And the agenda today, I'll give an introduction to what we see as what is nature-based climate adaptation against the storm surges. Then a little bit about how we develop these projects with a multidisciplinary cooperation. And then we have 4 very interesting examples here from Denmark. You can see them on the down right where they're located around the inner Danish waters, where this storm surge, Bodil, had a significant impact. But let's get on with it. So what is nature-based solutions? It's something where we work with strengthening the natural conditions against the storm surge in a natural and dynamic way. And we are trying to be inspired by natural landscapes elements that occur along our coasts, where and create habitats where animals and plants thrive. It could be, for instance, beaches, dunes, salt marshes, barrier islands, lagoons, cliffs, hills, and so on. We are using natural materials from clay, silt, sand, pebbles, gravel, and stones, surplus soil, a mix of it. And what we can do is we can make natural, varying looking schemes that are not as static. Ideally, we are trying to develop dynamically stable solutions both along the coast and across the coast that will reduce maintenance, but it's not a requirement. We can actually also create storm surge protection that will erode and change over time. Nature-based solutions requires a lot of space, and that's one of the challenges we need to solve when implementing these solutions. We can create nature. We can create nature at harbors and open areas, and we can also improve biodiversity by nature-based solutions. There's a lot of opportunities for creating recreational facilities, and we also have the opportunity to expand the protection over time to meet the future sea level rise, and that's very important as we are facing very severe forecasts for sea level rise in the future. It's a cheap alternative to hard protection in many places, and we're trying to minimize the extent of rock structures and concrete structures, and by doing that we can make a more natural appearance of the coastal protection. Rock structures that we do need can also be made into unique marine habitats. So how to develop these projects? We need, of course, to engage with the clients and the stakeholders. They need to define what kind of functional requirements do they have, what kind of budget do they have. And then we go into the machine room, so to speak, and optimize the solutions. We work together in a multidisciplinary teams with engineer, landscapes, architects, and environmental specialists to develop these solutions. And then we go back to the client, to the stakeholders, and to the authorities, and get feedback on our solutions, and thereby trying to optimize it. Go back in the machine room and try to develop it even further. So that's why we have the two different loops running at the same time in a series of iterations, and hereby get some very good and multidisciplinary and innovative solutions also developed. We can show some examples of that. Here we have Bogense sea dike. We have finalized site investigations, EIA, detailed design, and tender documents, so on, for this 8 kilometers sea dike in Bogense. We have both the urban environments and we have rural environments. So we have a lot of different solutions, and I'll go into some of them on the next slides. We are working with a 500-year return period event in 50 years' time, giving us a design water level of approximately 2.2 meters. One of the very severe challenges of this project is that we have a Nature 2000 area along the coast, and Nature 2000 is a very strict EU protection of nature. And we cannot really go into that area, so that sets a lot of limitations on our solutions. So we try to move the coastal protection back as much as we can. We're using earth dikes, and we are using bird rock revetments where we have more wave exposure. At the west side, we have a crest level of about 3.5 meters. And the east side, we have around 3.25 meters. And then inside the harbor, we can go a little bit lower because we don't have that much waves. Then we have 2 mobile storm surge gauges in the city center because we need to have some roads there. So here are 3 examples of the solutions developed for the western part. At the top, we have an existing sand dike. It's not really strong enough for the future storm surges that we are facing, the 500-year return period event. So therefore, we are changing it into a clay membrane dike, traditional clay dike, which is stronger. We have the grass and we have the clay to make it more durable towards wave attack. Then some of the soil that we excavate, we can put it out in front to make a small buffer against erosion. Then moving further east, we have less space. The foreland is smaller. So therefore, we are protecting the clay dike with a rock revetment. It's a very slim rock revetment with only 1 layer of rock armor. And again, we are trying to cover it with surplus soil to make it more natural appearing where that is possible. And before we actually cover it with these soils, we fill all the voids in the rock armor with sand so that we don't get cavities below. Then moving further east to section C, we do have more space. So there we abandon the existing sea dike along the beach, moving it back as much as we can along the road, and build again traditional clay dike there because the wave exposure is smaller. And then we remove all the rocks from the existing dike and let it erode over time. In order to strengthen the coast against erosion, we fill in the gap between the 2 different dikes with the surplus soil, so making kind of a back beach nourishment, so to speak. Moving to the other side of Bogense, we have more space, and there we have moved the dike significantly back. We are again abandoning the existing dike, moving the new clay dike back to the road, and hereby we create a nice environment with salt beach meadow, where we let in the water in one end in order not to create a big lake in case of overtopping. So here we actually let the water in, move the protection back quite a lot. Another example here is from Assens. We have a harbour where there's summer houses and all kinds of facilities, camping sites and residential housing. We are developing a 1.5 kilometer sea dike against storm surge and sea level rise. We're working with a 100-year return period event in 50 years' time. The design water level is about 2.5. And because we don't have waves at the same time as the storm surge, we have the crest level at the same level as the storm surge level. We have developed solutions that can be strengthened in the future to plus 3.5. Again, we have a mix of solutions both for rural and for urban environments. Again, we try to move the coastal protection as far back as we can. When we don't have enough space, as for the southern parts, we are developing a beach, moving the shoreline forward. We're trying to work with earth dikes because they're very cheap. We're using ramps as much as possible. Then at the backside, there are space limitations, and therefore we introduce sheet pile walls which we try to cover with vegetation and wood. There are some storm surge gauges because we need to maintain roads and accessibility around the area. We have made a very flexible plan, adaptable plan. We have a basic projects which exclude the northern part. There's a sea sports center there that can be included or excluded depending on their ability to pay for the protection. And then we have the length of the southern beach depending on how many of the summer houses will be included. So a flexible solution there. It's also adaptable. We have designed all the solutions so that it can be increased in height to 3.5 meters. And that also includes the sheet pile wall. Excuse me. At the northern part, we have some double protection in connection with the gates. So we have two lines of defenses. Excuse me. Here we have some of the solutions developed. At the northern part, we have a traditional clay dike because the foreland is large enough. Then we have sheet pile walls at the back where we have limited space towards the marina, where parking space for boats and cars are very important. Then at the very southern part, we don't have as much foreland, so therefore we create foreland with a beach to protect the new sea dike and also to protect the summer houses. Then we move on to Struer. It's a climate development plan we have made here. It includes water and 1.8 kilometer waterfront development. It's an existing industrial harbor that is transformed to a mixed-use development, which is gradually to be developed in the future depending on investors. And it's like an adaptive development strategy to accommodate storm surge and future sea level rise. We are working with a 100-year return period event, but then we're looking a little bit further out in the future to accommodate more sea level rise, so to speak. So we have a design water level between 2.6 and 3.1 meters, given a crest level of more than 3.4 meters. What we do here is that we make plans for each plot for gradually terrain regulation. We can gradually over time increase the level of each plot. We can try and focus, even in this, if this is an urban environment, try to develop green solutions to enhance nature. We're working with earth embankments, walls and ramps, and potentially also a beach. When we do a plan like that, we can see on the left we have storm surge protection, of course, along the edges. But when we do storm surge protection, we also create a barrier for runoff of surface water. So when we do this plan, we also have to take stormwater runoff into account. So developing this entire area gradually, we all the time need to make sure that water can run off at the surface. So these two different plans need to be developed simultaneously depending on the actual development. So here we can see some of the cross sections that we have developed, starting from section A. Here we have an existing exit road. An obvious solution here is to increase the road over time. That actually can help protecting the city center of Struer. And we also provide safe access during storm surge to the new area. Then section B is an area where we have existing houses and buildings that need to be preserved as they are. And here we need to make the storm surge protection in between these buildings. Here we have a square where we can increase the level of the square to protect the hinterland. We also have areas where we are developing housing. And some of these houses may have a small garden. And here we can hide some of the edge protection in the garden, make green edges, and make the protection as part of the gardening. On the outside, towards the semi-exposed sea, to the bay, we can make like a nature area with dunes and park, beach meadow, and that can be like a recreational value for a recreation area for a longer time before it can be developed further in the future. Then of course we can combine it. We can combine hard and soft edges, and hard edges alone, depending on the architect at the given time. The idea here is to preserve the existing water edge structure until it needs to be replaced, and then do gradually development of each plot depending on the investors over time, and then provide these different options for them. Then we have Rungsted Havn. Rungsted Havn is one of the bigger marinas here in Denmark. It has 750 boats, and the plan is to increase the capacity to 1,000 boats. We have developed 4 scenarios for maintenance and expansion of the marina. And when we do that, we look at the new elements that we have to do, then we can make the climate adaptation in the design of those particular structures. So we don't necessarily need to do everything at the same time, but when we do maintenance, when we do development, we include the nature-based solutions and the climate adaptation in that. We have again a 100-year return period event in 50 years time, and we are also looking 100 years out in the future for and making provision for future increase in level of these structures, so we can easily make the lifetime longer. We have a design water level of 2.4 to 2.85 meters, and the crest level of the breakwater is also varying depending on the wave explosion and so on, between 2.5 to 3.6 meters, with future potential to increase the crest level up to 4.4 meters at the most exposed places. One of the striking ideas of this project is that we have developed 5 types of beaches, both of course with recreational value, but also with 5 different technical purposes. Starting with beach 1 at the southern side, that beach is actually designed for a storm surge protection of the area south of the port. Then beach 2 is part of the main breakwater, where we include a reef, a rock reef, and a beach instead of a section of the rock revetment and the rock breakwater. Then we go to beach 3, which is actually inside the entrance to the marina, where we have today problems with wave disturbance. Then we can put a beach here to absorb some of the waves that are entering the harbor entrance. Then we have the northern beach, beach 4, which is also facing the waves here from the northwest. And that beach is actually designed to protect a part of the existing breakwater. So there we don't need to strengthen the existing breakwater as much as we should otherwise. Then beach 5 is actually a sand motor, where we can protect the beach towards north by adding more sand in that particular area and let it erode over time. This is the initial concept. Both the beach 5 and beach 1 is taken out of the final 4 scenarios that I'll come back to in the next page. So we are making an adaptable design of the breakwaters. We make a sustainable design, including dredge materials, surplus soil, and reuse of existing structures to reuse as much as possible the materials that are there already. We are trying to develop a green harbor with more nature and more biodiversity, green spaces. We can enhance recreational value, and hereby we can make a marina for everyone. A marina like this is not just for the boat owners. There's a lot of shop there, a lot of restaurants, and we want to make a site for everyone. Here we have the 4 different scenarios that are being under evaluation at the moment in the municipality. Scenario 1 is like the basic scenario, where we are primarily maintaining the existing facilities, maintaining the existing boat bridges. We are developing a new service quay wall, and we are providing a new access to the southern part of the marina, where we are developing this harbor park further. Then scenario 2 is like the next step. We are still using the existing breakwater, but we are trying to incorporate beaches on the front side of the existing breakwater, creating more recreational facilities and beaches. And again, the northern beach is protecting the existing beach. We are also here trying to protect the breakwaters against future sea level rise and larger waves. So we are putting another layer of rock armor on top of it. And then on the eastern breakwater, we add these bastions, and these bastions will try to maintain or catch some of the sand migrating along the breakwater today. And catching the sand forming beaches will also help reducing the sedimentation at the harbor entrance. So that's kind of the basic scenario, building on the existing breakwater. And scenario 3 and 4 are developing the boat capacity of the harbor to 1,000 boats. So we're building new breakwaters further out to sea. And again, we can develop that gradually depending on the funding. Scenario 3 is like the basic concept, where we develop the 3 beaches on the outer breakwaters, as explained before. The beach to reduce wave disturbance in the harbor entrance, the beaches on the north and the eastern breakwater. Then if we move on to the full scenario, we can add a lot of recreational facilities like extra boat bridges, viewpoints, and you can also see this central park area called Noggen, where we provide extra space, provide extra boat ramps, and things like that. So scenario 3 can be developed into scenario 4 over time, and it's only the imagination that puts the limit for all the facilities that we can include. The top, you see the visualization of beach 2. It can be very attractive for all the citizens in the area if we move beaches out on the breakwaters. Here we have some of the sections. We have a traditional rock breakwater on the left, and then on the very bottom we have the cross sections with the beach in front of the breakwater and the reef. And at the back we have the bastion that is actually there to stabilize the beach. And the bastions will also provide extra recreational facilities and space for developing recreational facilities on the breakwater, and thereby moving more attractive activities further out on the breakwaters. We also have the cross sections of the park at the southern part of the marina, where we do have space already today, but we can increase the natural value of that. Then on the top, beach 4, with strengthening of the northern breakwater with the small beach, the existing water depth is less at the northern side, so we don't need a rock reef there. So some of the conclusions: future coastal and urban harbor development must keep up with sea level rise. That's very important. We can make a gradual adaptation over time whenever elements need to be maintained or developed. So the solutions that we do implement need to be able to be strengthened and expanded over time. And here we have nature-based climate adaptation that has a lot of benefits. We can build it from more sustainable materials with a smaller CO2 prints, and that is often very cost effective. We can create recreational values, and we can also enhance urban nature and biodiversity. Nature-based coastal protection requires more space, and that's one of the challenges that we need to solve in our projects. And we do need hard elements. It's not so that we can only use nature-based solutions. We do need hard elements at some places with special functionality and where space are less. And we do need to recommend to minimize the mobile solutions. And the area where we do need the mobile gauges, we can make double protection to strengthen the protection scheme. One of the paradoxes working with nature-based solutions is that, of course, it requires more space, but that is sometimes in conflict with environmental protection, Nature 2000 areas, and other nature protection acts. And that's some of the main challenges that we're actually facing developing these solutions. And here you can see the image of the result the day after the storm in 2013. Because the storm surge level was that high, during the storm surge there was a lot of damage. The seawall collapsed and there was a lot of erosion. That was the picture we saw in many places during that storm. So we will face increasing challenges with future sea level rise. Even the storms may not necessarily get worse. So I think that was the end of the presentation, and then maybe we have some time for some questions. And thanks again for listening. One question is, are nature-based strategies being implemented to protect port facilities? And that's actually a very good question. And I think there's a lot of potential to include these greener and nature-based solution in port areas where we maybe have an industrial look as we have today, but by increasing the amount of nature-based solution, we can change the appearance of these port facilities. And again, there are many different options, both in the development of breakwaters, but also in the areas behind, to increase more, to include more nature-based solutions. Then there's something with artificial beaches. If we need to top up the sand from time to time, and yes, that is how beaches works, and especially these pocket beaches. They are designed to be stable, but there could come a severe storm surge that requires some additional beach filling. But generally, they are quite stable, and it is possible to develop quite stable beaches. But there could be a requirement for extra beach nourishment, and also when the sea level rises over time, that should also be maintained, or the beaches should also be maintained with extra filling to accommodate that. But that is standard when we design these structures. Yeah, then there's something about changing in participation, as well as sea level rise. Yeah, and that's again, we need to look at all different types of waters. It can come from below, it can come from rain from the surface, and it can come from the sea, it can come from rivers and so on. So all these things need to be taken into account when we do proper planning. And maybe some of these projects that I've shown, I haven't gone too much into that, but we do make a lot of detailed assessment of that also, parallel with the storm surge assessment. Yeah, I think some of the main obstacles for the future application of nature-based solution is that finding this space in the urban areas for it, and also for the to get the permitting right in a more rural area. Some of the changes or the challenges that we need to solve in the future, and maybe we need to have a look at the regulations there, and hope that they will be administrated more, a little bit less strict. And then some of the primary drivers for the nature-based solutions is that one of the paradoxes now is that it's very costly to develop these storm surge protection schemes, and we do have in Denmark a lot of surplus soil. So if we could actually use some of that surplus soil to develop these nature-based solutions, we can actually make the solutions much cheaper. We can create more nature, and hereby make a more cost-effective climate adaptation all along our coastline. And of course, one of the very obvious benefits is that we can create nature, we can create fresh recreational facilities and so on, and that's all something that will maybe have will be very strong compared to maybe more traditional hard structures that we often see around. But I think I think time is running a little bit for us, and there's a little bit of extra questions here, but I think I have to follow up, and then afterwards. And of course, you have my email here, and you are also very welcome to send email to me and contact me directly for further information or questions. But again, I'd like to thank you for joining the webinar, and hope you get some inspiration from some of our recent projects.